Okay. So basically my plan was to just kind of run you guys through a bunch of random R tips that I'm just like cobbled together quickly for this. If you've never seen R, this will probably be a little bit too over your head or quick, but if you use R a little bit, hopefully this is helpful for you. Um, okay, so first of all, I just want to give a plug for R Markdown files, which are this kind of file that you're looking at where you have these like code chunks, these little gray code chunks that you guys can see. So right, rather than like using, where is it? Like just a regular R file where you would just sort of like comment and write your code. Using R Markdown is nice for different reasons. One is that you can sort of like write all of your, oops, I don't know where I'm going. One is that you can sort of write all of your code and have it export as like a report. So for example, here is like how R Markdown, the code looks, right? But then when you like export it as like a report, like an HTML file or PDF, it can print not only your code, but also the results right below it. So it can end up looking something like this, where like I had a bunch of R code and I like sort of printed a report, so to speak. And you have like, all of your headers and graphs and everything like that. So this is like a nice report that you could like bring to like a meeting, for example, with, your advisor, and you want to like sit down and go through some preliminary analyses you've been doing, or like with collaborators, you want to send them an HTML or PDF file. So it's like a nice little analysis report you can just send people. It's good for yourself to quickly check back on something of like, oh yeah, what did the results look like for that one model or for this one graph? So just a plug for R Markdown and using that. You can also like even write your whole paper in R Markdown, and you can like set it such that the results get automatically linked. So if you ever update anything in your data, you just like rerun your code and all your results like auto populate. I haven't quite shifted to doing that process yet, but anyway, there's basically a plug for R Markdown and of like how things can look, and you can get this nice like table of contents and float around and whatever. Okay, just a plug for that. So now some random tips. I'm trying to keep track of the time here. I started probably like 10:50. Okay. If you want to load in a bunch of packages at the same time or all in once, this is the code you should probably use. So here you can just see like I listed out a bunch of packages, and I just like put it into a character vector, and then you can just run this one line of code and it loads them all in. So rather than having a million lines of code, we are like library this, then library this, then library this, then library this, right? You just have this like all at once. So great way to load a bunch of packages at once really quickly. This is, and I will share this script with you guys so you'll have more time to look at it closely. This is, when you get data from Qualtrics, oftentimes it looks like this, right? Where you have, you get these like, you can export things differently from Qualtrics, but oftentimes it inevitably does look like this, where you have these like first three rows that are kind of like headers, column names, labels, whatever. And like your data will start at like row 4 or whatever. And this is like the actual data. And R is great in that when you read in stuff, it like will automatically classify what type of variable each column is. But of course, it's going to screw it up for this because it's going to think, okay, this first row is the column headers and the second row is the data. So it's going to think that every variable in your data set is a character type because this whole second row is like character types, right? So it's going to misclassify it. And then now you're going to have to manually update the class of each variable or each column in R. That's a pain in the butt. So one way to like get around this, of course, one thing you could do sort of manually, you could like get the CSV here. You could delete these 2 rows, save the CSV again, and then import that into R. But I find that's a little bit clunky and like annoying. So alternatively, you can just run these 2 lines of code. This first line of code basically reads in your data, that CSV file, but it basically says like, don't read in anything, just read in like the very first row, like sort of the column name. So basically this first thing gets the column names for you, and then you rerun another line of code. This basically is the same function, this read CSV, where you read in the CSV again, the same CSV, and you tell it to skip the first 3 rows and then attach the column names that you grabbed earlier. So now what this will do for you is like now you'll have the R will read in the data and it'll automatically correctly classify each column, whether it's numeric, whether it's character, whatever, whether it's a factor. So that's great. So now you'll have everything correctly classified, and you'll still have your column headers and your variable names. So I find that when you have data from Qualtrics, this is a nice, quick, easy way to read that in and have it like instantly sort of organized for you. I find this useful, I guess, when I'm wrangling data. A quick way to remove spaces from all your variable names. You can just use this function string replace, and you basically just tell it to, if B is my like data frame or my data set, and I'm basically saying like, look at the column names of the data set and replace anything that has a space instead with an underscore. So now all the variable names will have, instead of spaces in the variable names, will have underscores. And that's great because R gets grumpy with spaces in variable names. So if you were like, political ideology was the variable name, but you had a space in between those two words, like that would be kind of annoying to deal with in R. So there's a quick way to like grab all of your variables at the same time and swap out any spaces with an underscore. Okay, glimpse and skim. These are two useful functions that allow you to look at your data structure or your data descriptives. So here's a data set, this MDL thing. And here I'm just grabbing a few variables for us to look at just to make things kind of smaller. So let's say if I were to run this, what glimpse is going to do is it's going to give you a quick sense of, what the structure of that data looks like. So it'll tell you here, is it a character? Is it a double, which is sort of like, in a way, sort of like numeric. And you can see sort of the first few rows, so to speak, of what the data look like. So it's a quick way to look at like, okay, what do these variables look like in my data set? Of course, you can run it across a much bigger set of variables than just, the 8 that I've grabbed here. But glimpse is sort of a nice way to quickly look at your data structure. And skim, we run that, but now use skim instead of glimpse. Skim is a good way to look at descriptives because it'll show you, my computer's being really slow today. Claire can probably relate. Yeah, normally it doesn't take this long to run stuff. Okay, but basically it'll show you, the type of variables you have. I have 3 character variables and 5 numeric, and then it'll group these variables by the type. So here are my 3 character variables. They'll tell you like how many missing values do you have? How many unique values do you have, right? So in this, it'll tell me, oh, you have like 9 unique stimuli in this data set. And then for your numeric variables, so the same thing, like how many missing rows do you have? What's that as a percentage? What are your means and standard deviations for each of these variables? And even gives you a cute little like histogram. And this is like very small, right? But if you're looking at just roughly like, is it bimodal? Is it super skewed? You can quickly glance across a bunch of variables, how they look. And while also looking at like mean, standard deviations, and if you have missing data. So I find skim a quick way to glance at just really rough descriptives for some of your variables, like a useful function. Okay, then we have functions called separate and unite that maybe you guys would at some times find useful. So let's say I make this data frame called, I guess I called it test, and it's going to look like, I think I already ran this code. So yeah, it looks like this. So here's this little data set I have. I have a variable called student with students in JSLab. I have a variable called favorite color, which is just some made up stuff I made up. And then PhD year, which I think is actually accurate. But so that's our data. Now, like, what if we wanted to split the variable student into 2 new variables called first name and last name? So you can see here, all of them are kind of neatly formatted where they all have first name underscore last name. So if I wanted to like take this variable and split it in and create a new variables called first name and last name, you just run this separate function. So you would take your data set, which is called test in this case, and just say separate the column student and separate it into 2 new columns, first name and last name. That's like what I want those columns to be called. And then this remove just equals false just means don't remove the original student column. It means just like keep that original student column. So we can run this. And now you will see we still have our student column and we have our favorite color in PhD year, but now we also have a first name and a last name column, and it's split apart the first names from the last names. So you can do that with your variables if you need to take a variable and kind of split the column into 2 or separate the character strings. I will make a note that R is automatically, as you can tell, recognizing that it needs to split on the underscore. So I feel like if all of your data are formatted in kind of the similar way, I think R will automatically detect on what to split on. But if not, like if instead of it had an underscore, there was like, it was Claire dot Robertson and Elizabeth dot Harris, like it had a period, you can just tell R what to separate on. And you're like, the separator is going to be a period or whatever, or a dash, or, whatever. So you can just tell it what to separate on too. So that's a quick way to separate. And you can also unite a variable, meaning like, let's say I wanted to take the variable student and PhD and I wanted to merge them into one new thing. So I'm trying to unite these character strings together. You can use this function unite, and you can basically say unite these two variables, student and PhD year, and we're going to call that, it's going to be called a new variable called student year. And again, this remove false just means don't get rid of the original student and PhD year columns. So you could run that, and now you have student year, where you have the student and then it appended on their year, right? So it's just merging those two columns together. So just a quick way to kind of deal with like merging text strings and or separating text strings out. And obviously it helps if things are sort of standardized or systematic, right? Because it makes your job a lot easier to split things apart if you know exactly where underscores or separators exist. Okay. I'm going to skip gather and regular expressions for right now, because I'm pretty sure that will push me much over my 10-minute time, and show you like last couple things. Okay, so for this, I think oftentimes quickly look at a table of your data. So here's a data set, MD, and we're going to look at the table of race. So you would look at it like this. I think a lot of people are probably used to this function table. And you get your table here, so you can see like how many people are in our data set of each race. But this is kind of like I find clunky and not pretty way of looking at this. If instead you load in the janitor package earlier above in your series of packages that you load in, you can use this function called table, which is just spelled weirdly, like tabule. But it's actually a much prettier way to look at that data. So instead we can take our data and just run that function on it. And instead of this kind of like awkward looking thing here, it should pop out with a prettier version of it, which is like here, right? So you can see this is actually much easier to read. And not only does it give us the ends, but it also gives us the percents, and it gives us the NAs by default. This will also give you the NAs if you do like use, I think it's like use NA or something like that, equals true. But it's not the default, right? So you have to like remember to like, oh yeah, there it is, use NA. So yeah, so this table, tabule, whatever I still call it, just table, is like a nice way to look at the data. You can also make it even prettier. You can adjust how these percents get formatted. And so you can just do that. So now I've formatted the percents to round to 2 decimal places. And right now it's really quick to be like, oh, I had 15% Hispanic or 16% Hispanic in my sample. So it's a good, quick way to look at tables for different variables, right? You can use this for whatever. And of course you can, continue piping and use your tidyverse skills to just arrange the data. And so now you have the data arranged from low to high based on the ends. So yeah, so I find that this table thing is a nice, a much nicer version to look at tables of data. Yeah, and you can read more about it here. Okay, next thing is how to create your own ggplot theme. So for those people who use R, you might be using ggplot to create plots, and you might constantly be adding lots of lines of code when you have to customize things about the theme, like what is the size of the title and what is the size of the font and the x-axis labels and all sorts of things, right? That you're like each time customizing, and maybe you're copying, pasting, 10, 15 lines of code each time to each of your plots. You can skip a lot of that. I learned this actually very recently, sadly. I mean, it's not sad that I learned it. It's just sad that it took me forever to get around to learn this. But basically, you can make your own ggplot theme by just writing this function. And basically, what you're doing is sort of borrowing an existing function, and an existing theme that R or tidyverse has. And in this case, it's theme classic. And then basically, you're just replacing certain or updating certain elements of it. So here you're saying like, oh, I want the size of the title to always be 26, and I always want it to be centered, and I always want it to be bolded, right? And there's a million different things that you can edit here, like the axis title. And if you just, I'm pretty sure if you just Google, or maybe even if you just like looked up the documentation for theme itself, you would see what all of these different like things are that you can put in here and edit. You can see I'm commenting what these things are doing. But yeah, basically you just update whatever you want and you standardize your plot. You're specifying what the font will be, and then I just like to call it theme classic Diego, because so then I'll know it's like it's the theme. It's based on theme classic sort of defaults, and then I've sort of customized it to make it my own. So I could like run that this function, and then you can just like tack it onto your plot, right? So then you can have your ggplot, and then now you just have this one line of code, and it's going to standardize how everything looks. And if I'm lucky, I already ran that maybe. Yeah, it looks like it's running. Sorry, my computer and R are being molasses today. I'm probably like at 15 minutes. Jeez. Well, whatever. A plot will appear here in like 3 hours. Okay. The next thing I was going to show you, oh yeah, half violin plots. Those are nice. If I can find it here. Just a plug that there's this thing called in ggplot called geom violin dot, which automatically will give you these half violins, violin plots. It also will plot like the data stacked this way for you. So it's kind of a pretty way to look at the data. And so just to plug that, this is a new, I think a newish function, violin dot, that's part of this easy stats suite of packages. So just know that this exists, and you could run this very quickly and get pretty plots. Okay. This is an example of like how I didn't color code it and make it color pretty, but like you can see here's the half violin bot and here's the stack. This is like actual data. So you can see how it actually looked for something. And then I added means and standard errors to each of the columns or time points. What else do I have? I think that's like almost it. Oh, I guess I have one more thing. Okay, regression output. So let's say you run like a mixed model, and you're predicting some variable from like all these predictors, and then you have some like random intercepts or whatever. You can run this mixed model and call it fit. I think I might have already run this, hopefully. And then you can use plot model to look at the estimates. So that'll probably take a minute to run, just because my computer's been so slow today. Wow. Well, I promise. Normally this code should take like literally half a millisecond to run, but I think maybe because I'm on Zoom and trying to run R code, R is grumpy, and because my computer is like 8 years old. All right, but you get a plot like this. It's plotting all the estimates for you, right? And so you can look at, and I've arranged them from like largest to smallest or highest to most positive, most negative. So you can see like what's the biggest predictor of in that regression. So it's a nice way to look at that data. I know there's a lot of code going on here, but basically it's just this plot model thing, and I'm just plotting the fit. And then all of this other stuff, all of that's just like customizing the size of the dot and, you know, show whether to show standard errors and that kind of thing. But basically the basic of it is just plot model and fit, which is what I just saved my model into earlier. Okay, so normally when you run that, let's say you run that model, one way, instead of like visualizing it, you just want to look at the actual output. Most people will run summary fit, and you'll get this really gross looking, like, you know, I don't know, to me this is just like, what, it's just so much random text. But yeah, like here's your output, and good luck making sense of all this, and here's your regression table of your fixed effects, and here's your correlation of like, it's not pretty. Instead, you can use two things that I find, I haven't picked which one I like best, but they're both pretty good: sum or tab model, as better ways to look at that data. So if you run sum on that model, instead, it will print out a much cleaner version of all your regression output. That looks like this. So you can see this is like way more organized and well labeled. So here we have like our model info. Here's the model fit. Here are the fixed effects that are like neat columns. Like you can see I specified to only show 3 digits. So it only has 3 digits, gives your estimates, you know, all that kind of stuff. So it's nice to see all that. You can look at your random effects and your grouping variables. And you can even mean center your continuous predictors right in this. I didn't even have to, if you notice above, I wasn't like, well, actually, it's hard to know, but I had not mean centered these variables here. But you can actually do it in one step here when you're looking at the output of the data.